Okay, so welcome to the second part of the Max Flow Min Cut series of videos. So we're looking now at the minimum cut. So we learned in the last part what a cut is and what to do to make sure we find what its cut capacity is. So what we're going to do here is we're going to try and find every possible cut in this network and try and figure out which one the minimum cut is, which is the cut with the smallest capacity. All right. So what we can do, start drawing some cuts in. Now, a cut is a line, basically. We can do a circle, but I think a line might be easier. We have to make sure that it cuts off the sink from the source. Okay, so we can see that there's no way that anything can flow from there to the sink that way, from the source to the sink that way. And if we try and go this way, it's going to hit the cut there as well. So that's a valid cut. Now, what's the capacity of this cut? Well, seeing as there's going to be quite a few cuts that we're going to make, I'm just going to call this C1 for cut 1. And we'll say that C1's cut is going to be, remember, we're only adding numbers that go from the source to the sink. So we can add this one. We can't add this one because that goes from the sink side, the sink side to the source side. But we can add this one because that goes from the source side to the sink side. So we can add those two. 2 and 2 make 4. All right. So that's C1. Can I do this? Look like I can. That cuts off the source from the sink. So we'll call that cut 2. So what's the cut 2? Well, both of those edges go from the source to the sink, so we can add them both. 2 and 1 make 3. Let's do another cut. We can do similarly on this side. We can do a cut and call that cut 3. And yes, we can add both of those numbers because we can tell from the direction that that goes from the source side to the sink side. 2 and 1 make 3. Is there any others? Yeah, we could mirror the C1 cut and cut along this way as well. And we can see that this goes, that one we can add. This one, can we add? Yes, we can. Remember, when we went this way, we couldn't because that made this going from the sink to the source. But because we're cutting this way now, we've got the source on the correct side. So we can add that. And of course, we can add that one as well. So 1 plus 3 plus 1. And then we'll call that cut 4 is 5. So the minimal cut capacity is going to be 3. The min cut capacity is equal to 3. All right. So why do we do this? I think we're about to find out. So that's where the maximum flow minimum cut theorem comes in, okay? There is always some flow and cut with equal capacity, all right? When this happens, the flow is the largest possible and the cut is the smallest possible, okay? So if we think about this same diagram as we did before, and we use this theorem where if there is a flow and a cut with equal capacity, that will be the maximum flow and the minimum cut. Let's think about, we know that we can see that out of all of the cuts, the minimum cut was 3. So how can we know that that's the maximum flow as well? Well, all we have to do is find a flow of 3. All right, so let's have a look. When we think about flow, what do we mean? It's a different thing to finding a cut. So the best way I found to show this is if we have, imagine that these are all pipes, okay, and those numbers, those numbers represent the capacity, the flow capacity, like we were looking at with that example before with the pipes from the house. We could say that this has a flow of 2, this has a flow of 1, this is a flow of 3 in this direction, this is a flow of 2, and this is a flow of 1. Okay, but realistically, that's not technically possible. Okay, we can immediately see that pipe in the middle, it's never going to get a flow of 3 through it. Why? Because it comes from this pipe that only has a flow of 2 through it. Okay, and so we have to be a little bit more mindful about how we're representing these flows. Okay, so let's undo what we've done so far and start at the beginning. So what we can do is we can go, there's a flow of 2 through there, okay, and I can therefore put both of those 2 through there, and then I can get 2 through there. But that is a flow of 2, right? And we're trying to show that our maximum flow matches the minimum cut of 3. So is there another way of doing that flow? Well, maybe. Let's have a look. What if we go back to the start again? We still have 2 coming out here, and we still have a net, but now we have 1 coming through there as well. Okay. Obviously, we can't have 1 coming from there going this way because the flow, the arrow suggests that it's actually going this way. Okay, so we can't do that. So what we might do is first we'll send that flow of 1 through that pipe there. Okay, and that deals with that one. What we could also do now is we could send either both of our flows through there, but that restricts what can go through there now. Okay, that means only 1 can go through there, right? But what we might be able to do, and that will end up with a total flow of 2, but what we might be able to do is we can send one of our guys through there, all right, and this one that's going through there can go through there as well. Okay, so then that ends up with our total maximum flow being 3. All right, and as soon as we find that maximum flow, we know that that equals the minimum cut, therefore that is the maximum flow. Okay, all right. So now what we'll do is we'll look at a bit more of an example here and a bit more context behind that example. All right. So this might be representative of liters per minute through some piping, or it could be the speed of data going through cables in a network of computers. We don't know yet, but let's think about how to approach this problem. Now, it says find a flow of 150 units from the source to the sink. Well, there's not many different options, but we can go this way, or this way. Okay, pretty clear 3 pathways through from the source to the sink. So we can go 60, and that speeds up to 80, but what's going to happen, right? The capacity, or the flow, sorry, the capacity is 80, but the flow through there is 60, and the flow through there will be 60. So there's the flow of 60. Here we've got a capacity of 30, but our flow is going to be 30, but it's going to slow down to 20. So there's our capacity there, or our actual flow. And finally, if we look at this, we've got a capacity of 110, then that drops to a capacity of 90, it drops again to a capacity of 70, and that's what ends up going through there. Okay, so if we do our cut through these lines here, 70 plus 60 plus 20 gets us an answer of 150. Okay, And that's where we do our cut. Now, to prove that this flow is the maximum possible, all we had to do was do that cut. Okay? So minimum cut is equal to 60 plus 20 plus 70. It leaves us with an answer of 150, which matches a flow of 150. Therefore, max flow is 150. All right, and we'll leave that there, and we'll conclude in the next one.